Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. Today I want to present about my project. The title is Assessment of the Orbital Elements of Razaksat using Keplerian Orbit Model and SDK. My name is Muhammad Zahri Hassan. Okay, I'll start with introduction. In the satellite subsystem, they have four main important components that use in the satellite. So we call the first subsystem we call TTNC, stand for Telemetry Tracking Command. And secondly, we call ADCS for Attitude Determination and Control System. And third, we call CNDH Command Data Handling. And lastly, we call EPS Electrical Power Subsystem. So for my research, I'm focused more on the ADCS. So ADCS are divided by two parts. First, we call Control Subsystem. And second part, we call Determination Subsystem. So in my research, I am focused more on determination subsystem. Okay, for ACS stand for Attitude Control System, consists by two parts. First we call Attitude Control System, and one more part is called Actuator. So ACS function for the stabilization and the control the startup attitude. Meanwhile, ADCS have a attitude estimation algorithm and the sensor. So the function of ADS is to measure the vector of inertial reference and compute the orientation and position of the satellite relative to the Earth. So problem statement. During satellite enter the orbit, there are many disturbances such as solar radiation, gravity, albedo phenomena that can affect the orientation of the satellite in terms of orbital position. Especially in the near equatorial orbit, and of course, Malaysia in the near equatorial orbit can increase the risk of radiation damage to the satellite. So that's why satellite orbit data is need to investigate the orbital position. However, the experiment in the space environment to improve the accuracy and the computation time is impossible due to the costing and of course more facility. So that's why Razaksat data is NICO orbit, such as the satellite orbital position used for the investigate the orbital position. So for this project, I implement the parameter of Keplerian orbit model as the orbital model and SDK method and comparing or justify with Razaksat data. So next, and go to the Keplerian orbit model. Keplerian orbit model is based on the Keplerian equation for elliptical orbit. They have 6 elements of 4 orbit and represent as mathematical equation such as mean anomaly, eccentric, ascending node, argument perigee, orbit inclination, and semi-major axis. So these 6 elements we describe which mathematical equation for elliptical orbit. So next, SDK. Satellite to skills, or we call the SDK, is open software. They simulate the vehicle navigation and communication. This is great news for the satellite developer. For before can simulation the satellite orbit before sending the or test the satellite in the space. So SDK can well design and develop complex and dynamic simulation for real problem that have to do with ground vehicle, aircraft, spacecraft, and satellite. So I go to the methodology. Okay, so methodology start with the TLE. TLE data for Razaksat. TLE data, TLE data, TLE is the initial information of the satellite orbit and the basic data used for calculating the position vector in the orbit. So position vector start with calculate uh, by extracting or choose the TLE to get the satellite epoch time. It means initial time during the satellite enter the orbit. So by use this information and we use this initial orbit elements at the epoch. Then from the information we get the satellite entered orbit, and we use the orbital model, Keplerian orbit model, and STK to generate orbital elements. So the orbital elements have three parts. First we call ECI frame, and secondly we call ECF frame, and lastly we call LLA. This orbital element we describe in the result. So for the orbital element and orbital element equation, but this is what we use for the mathematical equation for ECI frame, ECF frame, and LLA. Now we go to the result. So based from the result, we analysis in terms of ECI frame. So I'm use the Keplerian orbit model and STK and comparing with the Razaksat data. By using the maximum error, percentage error, RMC, and MNE, and standard deviation, we analysis a three-part X, Y, Z axis. So from the result, we can see this Razaksat and Keplerian orbit model and STK give the same pattern, trend line, same line with the Razaksat data for the three axes. So from the result, ECI frame, percentage error for Keplerian orbit model and STK compared with Razaksat is less than 5%. So this means that STK is more, from this result, STK is more accurate compared with Keplerian orbit model. Meanwhile, for ECF frame, same with ECI frame, Keplerian model and the STK compared with Razaksat data for three axes. So of course, we analysis on the maximum error, percentage error, RMC, and MAE, and standard deviation. So ECF frame, same with ECI frame, give the line, same line pattern line with Razaksat data. So from the analysis, we find what we got the ECF frame. Percentage error of Keplerian orbit model and STK with compared with Razaksat is less than 5%, same with ECI frame. So Keplerian model is showing maximum position error and percentage error is better than STK in terms of RMC, MAE, and standard deviation. So now we go to the LLA. So LLA for analysis, latitude and longitude and altitude. Same with ECI, ECF, and LLA. So ECI and ECF, but for LLA, the latitude give the accuracy same with pattern for Razaksat. However, for the longitude, the rectangular pattern graph, maybe I think it is maybe disturbance from the Razaksat when you enter the satellite, and of course the altitude have a little deviation compared with the satellite to compared with Razaksat. So from this analysis, what you get, the trend line still same with Razaksat and still relevant verification that Razaksat following requirement design and satellite position. So from this result, Keplerian model is still relevant for LLM verification and same with STK. So conclusion, Keplerian model was successfully implemented and enhanced as well as compared with the near equatorial orbit of Razaksat. The reliability analysis for orbital data with satellite analysis approach using STK software was successfully conducted. The trend lines are still same with Razaksat and still relevant for verification that Razaksat following requirement design on satellite position. Mathematical models such as Keplerian alternative for estimation to prove the Razaksat maintained in right position in terms of ECI, ACM, and LLA. So I think that's all for my